right, here we have two vectors given to us, vector A and vector B, and they have provided us with their component forms. Now, the question that this problem wants us to address is what the magnitude and direction of 3A minus 2B would equal. Now, if you haven't watched any of the previous videos and you're coming to this fresh, be mindful that you'll need to know what it means to multiply by scalar multiples. That's how we work with the 3 and the negative 2 that are here. And you'll also need to understand basic vector addition, which is just combining vectors together. Traditionally, when I do a problem like this, my inherent goal, my initial idea of what to do, is going to be to essentially something kind of like the distributive property. We're going to do 3 times all the things in A, and then we'll do negative 2 times all the things in B. And then whatever I get for those pairs of x and y components, I'm just going to add those together. So that's going to generate component form for my resultant vector. What it doesn't do for me is it does not provide me with the magnitude and the direction directly, which is the idea behind direct notation. So that's our goal here. Now that I've rambled on for a good little bit, let's go ahead and start off with what we've talked about. We said let's go ahead and deal with 3 times A and negative 2 times B. 3 times A, very straightforward, so that's going to be 21 and 36. And then for our negative 2 times B, we're going to have negative 2 times a negative 5, which would give me a positive 10. And likewise, negative 2 and a negative 4, we're going to get a positive 8 here. And so even though this one here has us working with double negatives, we're kind of subtracting that vector. We were doing the opposite of that. So we end up with all positive values here, which is pretty nice actually. And when we add these together, let's just go ahead and put those over here to save some space. We just add our respective components. We'll add our x components together, and we'll add our y components together. So 21 and 10 would be 31, and then 36 and the 8 would give me 44. Now, as we said, this right here is the vector we're looking for. Our vector is the vector 31, 44. But those are the x and y components. It's said to find the magnitude and the direction, though, so always make sure that you're answering the question that they are giving you. So, other topics from previous videos, we're seeing multiple layers here as we continue through these problems. We need to be able to find magnitude. We need to be able to find direction. But thankfully, magnitude, we talked about how it's really related to drawing a right triangle and thinking about the Pythagorean theorem. All you have to do is take the square root of the sum of the squares of your x and y components. So I said the sum, or the square root of the sum of the squares of the x and y components. That sounds like a lot. If you don't like what we just talked about here, just think about it this way instead. We have 31 to the right, we have 44 up, and we want this resultant vector that we get from it. Well, Pythagorean theorem, this squared plus that squared equals this squared. So take the square root of those guys together. We'll check that out here in just a moment using a calculator. We'll get that value. But I want to go ahead and set up our direction as well. I like to do all the calculator stuff at once if it's all independent of each other. Now, since I already drew a picture here, this one we can see is going to be really nice. We're dealing with all positive values, so our angle when we use the calculator will be perfect. But just know that there are times where you're going to have to go in and address whether or not the angle the calculator gives you is actually the angle you're looking for. So here, since we're working in the first quadrant, that's always super cooperative. All you have to do to find theta in the first quadrant is just go ahead and find the inverse tangent of your y component divided by your x component. So a lot of words here, a lot of, somewhat rambly kind of mentality, but we're at the end of the problem. We just got to get those values. So 31 squared plus 44 squared. I'm just typing all this stuff in at once. I know some people like to go ahead and square each thing and then add them and then square root them. To me, that just seems like a lot of extra work for no reason. I'm going to go and check my mode here. So we can see on my calculator, I must have already been doing this previously and not cleared my calculator. I already have degree mode set up. Traditionally speaking, when we work with vectors, we deal with degrees. That's not to say that you couldn't use radians, but it's less typical. So just be mindful, they could ask you if you're working through a problem for school, or if you were just out in the world and somebody wanted to measure it in radians instead, they would specify that, and you just work with it. Having said all that, that's not super relevant because we're just going to go ahead and leave it there. Let's go ahead and get these values typed in. Tangent inverse of 44 over 31. Interestingly enough, these two numbers ended up being very similar. That's a coincidence. They're not related to each other in that way. That's just the way this one worked out. So for my magnitude, let's call it 1 decimal place since they didn't specify. We'll say 53.8. And unlike in a previous video, I will not make the mistake of putting a degree symbol on that one. This is the magnitude of the vector itself. And the 54.8, I'm going to call that one about 55 degrees. I like to round degrees to whole numbers. Now that's a personal preference. That is not something that you have to do. But we're done. We know that 3a minus 2b is the vector 53.8, comma, 55 degrees. And this is kind of a weird way to write this for some people. It sounds like we're saying it has two different answers, and it kind of does. Remember that all vectors will be defined by a magnitude and a direction. So if I want to give this in direct notation, I have to have both of those things. It's worth noting that in component form, again, this is magnitude and direction. It's saying to the right and up. That's how the positive values here tell me direction. They say go right and up. And it tells me how far to the right and how far up I would need to go to get that same resultant value. Okay, so that's all there is.